Hi everyone, I'm Sebastian Perez and welcome to this series where you are learning how to build efficient hooks using Uniswap Hooks Contracts Library. In the last video, we looked how to implement dynamic fees using different approaches. In this video, we'll dive into two hooks. The base custom accounting hook, which allows you to have full control of the liquidity in your pool through the custom accounting logic, and the base custom curve hook, where you can define custom curve calculations to control the swap logic. Using these base hooks gives you the tools to create new DeFi strategies on top of Uniswap v4. Let's get started. The base custom accounting contract is an implementation that enables you to manage hook-owned liquidity for your pool. It shifts control from the default liquidity mechanism to a developer-defined approach, giving you full flexibility over how the liquidity is managed. The core logic of this hook is defined in three key functions. The add liquidity function that allows the users to deposit tokens into the pool and receive liquidity tokens in return. And then to make this work in our hook contract, we have to manage the liquidity token and also override the get add liquidity to indicate the amount of tokens that will be minted. The second key function is the remove liquidity that enables users to withdraw tokens from the pool by burning their liquidity tokens. Similarly to the add liquidity, you have to override the get remove liquidity to get the amount of tokens that will be burned and also manage the liquidity token. And finally, the unlock callback that is triggered during the liquidity modifications, whether adding or removing liquidity. It applies custom accounting logic to manage token transfer between the hook and the pool, ensuring that all the operations respect the defined liquidity parameters. To implement our hook, we have to inherit from the base custom accounting and override the constructor the liquidity tokens related functions that they are mint and burn. To handle both, I'm using the ERC20 contract from the OpenZeppelin contracts library. Then we have to override the get add liquidity that will be used in the add liquidity function. This code has to define how the liquidity parameters are calculated to indicate the amount of tokens that will be minted. For this example, we are using a library that is called liquidity amounts that will calculate the liquidity based on the parameters that are received from the function. And lastly, the get remove liquidity that, similar to the get add liquidity, will be called by the remove liquidity function. And in this example, the code do the maths to calculate the user shares, and this will determine how many tokens should be burned. This hook is very useful as a single entry point to add or remove liquidity, but you have to consider that it works with just one pool key. Now that we understand the flexibility of the base custom accounting contract, let's explore the base custom curve that builds on top of this hook and implements a custom curve for swap logic. Let's take it one step further with the base custom curve. This hook builds on top of the base custom accounting, providing not only the liquidity management, but also control over how the tokens are calculated during the swaps. Let's explore the code. When inheriting from BaseCustomCurve, you need to override some functions. First, the constructor that is always the same as in the previous examples, but adding also the constructor override for the ERC20. Then we have the liquidity token functions related that handle the minting and burning of the liquidity tokens when the liquidity is added or removed. The get amount in that defines the units of liquidity tokens to mint based on the input parameters. This function is called in the get add liquidity from the base custom accounting to set the liquidity attribute for the add liquidity function. In this example, it averages the two tokens amount, the amount 0 desired and the amount 1 desired, to determine the liquidity tokens to mint. Get amount out determines the amount of tokens to return and the liquidity tokens to burn when the liquidity is removed. In this example, this assumes an even split of liquidity between the two tokens in the pair. And lastly, we have the get unspecified amount that determines the amount of the token that is not specified in the swap, defining the curve logic for the trade. In this example, the tokens are exchanged at 2-to-1 ratio for both exact input and exact output swaps. And that's all. The BaseCustomCurve contract defines these amounts to create a custom curve for swaps, while leveraging the hook-owned accounting functionality from the BaseCustomAccounting contract to manage liquidity modification effectively. Now that we explored both the BaseCustomAccounting hook and the BaseCustomCurve hook, you should have a solid understanding of how Uniswap hooks empowers developers to customize Pulse logic on Uniswap v4. Do you have any other examples or use cases that you'd like me to cover in future videos? Drop your suggestions in the comments. If you found this video helpful, don't forget to like, subscribe, and turn on the notifications so you won't miss future videos. Thanks for watching, and I'll see you in the next one.